Today on the Perception in Action podcast, what is the difference between using online versus offline information to control our actions and direct versus indirect perception? How have these been used incorrectly in many attempts to integrate skill acquisition approaches? An attempt at some clarification. So it's time for a call to action. Hi, this is Rob Gray from Arizona State University. I've been on a now over 25-year journey as a researcher, professor, and high-performance consultant to understand how we acquire and adapt our perceptual motor skills. Welcome to the Perception in Action podcast, where I discuss how psychological research can be applied to improving performance, accelerating skill acquisition, and designing technologies. Before we get to today's topic, I want to tell you about my new book. Yes, I've written a new book on skill acquisition called How We Learn to Move, a revolution in the way we coach and practice sports skills. It covers the ecological approach to skill from different angles, including practice design, the CLA, coaching, youth sports, designing technology, injury prevention, and using analytics. So I hope you will consider giving it a read. You can find the book on Amazon or by going to perceptionaction.com/book. Now on to the show. In today's episode, I want to attempt to briefly clarify something that I see as a persistent source of confusion for many people. That is the distinction between online and offline information on the one hand, and direct versus indirect perception on the other. Through doing this, I want to try and understand something that has me a bit baffled. Why are there so many people out there that seem to want to cling on to the ideas of Gibson's theory of direct perception, and by extension ecological dynamics, when clearly they do not believe the theory is correct? But we'll get to that. To start off with, let's think about returning a tennis serve. As it's typically defined, offline information refers to information that can be used to control the action that is present before the event begins. In this case, we can call the start of the event the ball being struck by the server. Examples of offline information include situational probabilities. This opponent likes to spin the ball cross-court when it's her second serve. Court position. The server stands closer to the center line when going cross-court. And advanced sports skills. The server bends their knees more when they're going to do a hard serve down the center. Including online information, as typically defined, refers to information available from the environment after the event begins. The classic example here is tau. The inverse of the rate of expansion of the ball's image specifies the time to contact, how long it will be before it reaches you. There are also online information sources about direction, your opponent's positioning, etc. For a great discussion of this, I would recommend the 2012 paper by Mueller and Abernathy, Expert Anticipatory Skill in Striking Sports, a Review and Model. So here is the main source of confusion I see. It seems to me that many people think that using online information to control your actions, whether it's tau or something like optic flow, is synonymous with direct perception. This is simply not the case. You can use tau to control your racket movement in tennis without it involving direct perception. Before I explain how, let's define the other dichotomy. And yes, it really is one: direct versus indirect perception. For this, I'm talking about Gibson's theory of direct perception and how it's used as part of ecological dynamics. As I will consider in a moment, maybe there are other ways to define direct perception, but in the context of the sports discussions I'm having, when people use the term, they're talking about Gibson's ideas. As defined by Gibson, direct perception is the idea that every action relevant property is directly specified by information from our environment. Stated another way, we can control our actions by directly picking up information without the need to process, weight, or combine the information, or use any internal mental model. The information on its own is sufficient for action control. We just need to pick it up and couple our movement to it. Or as Bill Warren wonderfully put in his recent paper, perception is the ecologically well-posed problem. Indirect perception, on the other hand, begins with the assumption that perceptual information we get from our environment is insufficient and impoverished. It needs to be interpreted using previous knowledge and/or mental models. As Bill puts it, in this approach, it is assumed that perception is an ill-posed problem. There's not enough information there to act. The classic example of this is depth perception. The perceptual cues we get on our retina are 2D, while we need to reconstruct the 3D world around us. For more information on this distinction, I would recommend checking out episode 20C of the podcast or Bill Warren's article I mentioned. I have linked to the video review I did of it in the show notes. But hopefully you can see there's a dichotomy here. Information from our environment cannot be both sufficient and insufficient for controlling our actions. It's like the Earth being both flat and round at the same time. They are incompatible ideas. But let's return to the source of confusion. Let's develop a Bayes model for a tennis serve. Imagine that our player waiting to return the serve is trying to predict whether the serve is going to go down the line or cross court so that they know where to move, left or right. Before the server does their ball toss, the receiver can start generating an internal model to predict direction based on Bayes' theorem. From previous experience, they know that the opponent serves cross court 80% of the time on their second serve. Thus, they can generate a tentative prediction using offline information. In this case, what is called a contextual prior. The context being the fact that it is a second serve here. During the ball toss by their opponent, this prediction can next be updated by a new source of information that becomes available. Advanced cues from the opponent's kinematics. Say, for example, that 90% of the time the opponent does a deep knee bend when they serve cross court. Finally, once the ball is struck, online information can be brought into the internal prediction model. Specifically, when the ball starts moving, the launch angle will give information about its direction, tau will give information about time to contact, etc. So this can be pulled into our Bayes internal model and combined with other information to make the prediction the ball is going cross court. This prediction is then presumably used by a motor program to generate a stepping movement to the cross-court side. We could also have an analogous model for predicting whether the serve is going to be short or long that incorporates tau, for example. For a detailed example of this type of Bayes model, see the link to the article by David Broadbent and colleagues in the show notes. The problem is not with the model here. The problem that I see is that it seems like for many people out there, what I've just described is an example of a model that successfully integrates indirect and direct perception. The indirect part is the use of knowledge about the opponent's tendencies. The direct part is the use of tau. Well, I'm here to tell you that's completely incorrect. Bayes models, like the ones I described, are models which combine online and offline information, not ones that combine direct and indirect perception. Gibson's idea of direct perception is that information from the environment is sufficient to control our actions. It directly specifies the action-relevant variables we need to move. There's no need to predict anything or weight information based on prior knowledge and context, which is clearly being done here. A Bayes model starts with the fundamental assumption that information from the environment alone is insufficient. But Rob, what about if the player does the Bayes prediction stuff before the ball is struck and then couples their movement directly to tau once the ball begins moving? Isn't that integrating theories? No, it isn't. The presence of the prediction component means that you assume that perception is indirect. The information from the environment needs enhancing. It is a model that again combines online and offline information, not direct and indirect perception. Any model of skill with an indirect component is an indirect model. You simply cannot combine ideas like prediction, mental models, contextual priors, prior knowledge, with direct perception. They go together like oil and water. So the bottom line here is that if you combine any type of predictive internal model or one that processes and combines information like a Bayes process with online sources of information like tau and optic flow, what you have is an indirect perception model that uses both offline and online information. Flipping to the other side of the coin, you can also have a direct perception model of control that uses quote-unquote offline information. An example of this can be seen in the model I described in my recent review paper on baseball batting, link in the show notes. As I discuss in the paper, a batter does not necessarily need to use the kinematics from the pitcher's delivery to predict the type of the pitch, what would be indirect perception. Instead, there's information from the pitcher's movements they can use to directly control the weight shift on and off their back foot by coupling to this information, without a need to make a prediction or process the information in any way. And as discussed back in episode 336, it is possible to generate anticipatory behavior, which is assumed to be only possible using an offline prediction, directly using Turvey's concept of strong anticipation. Another point that seems to give people a lot of confusion is the belief that you cannot use perspective, information movement coupled control in the absence of online information. For example, when a player turns their head away from their target or the ball to look at something else. A baseball outfielder looking at the wall so they don't crash into it is a specific example. As I discussed in my aforementioned baseball paper, this does not require some internal model or prediction to handle. If the performer establishes a perspective control law and nothing else changes, they will achieve their goal if they keep doing what they're doing, even if online information is taken away. This fits with the concept of a relaxation of an attractor that Bill Warren has discussed. Again, see my paper if you want more details. So the bottom line is you can have indirect perception models that use both online and offline information, and direct perception control models that use these information sources as well, but in a completely different way, of course. Offline versus online and direct versus indirect are completely separable constructs. To end today's episode, I want to return to the question I raised earlier. Why do people that believe in mental models, predictive control, the use of contextual priors, etc., seem to be frequently also wanting to cling on to the idea of direct perception, when clearly they believe it's not correct? You can't think that we need mental models, prediction, etc., and believe in Gibson's concept of direct perception, and by extension ecological dynamics at the same time. They just do not go together. So let's explore a few reasons for this desire to cling on. Reason number 1. Being cynical, but I do believe this is the case for some, I think there are a few people out there that see how popular ecological dynamics is becoming. I hear there's a hot new selling book about it out there now, wink wink, and they're worried about losing business. If this is the case, then I think the most productive path is to write and publish a detailed, evidence-based critique about ecological dynamics, explaining why you feel it's fundamentally flawed. Because if you want to incorporate internal mental models, etc., into your coaching, then as I've tried to explain today, by definition, you believe that its very foundation, Gibson's theory of direct perception, is flawed. Reason number 2, and I think this applies to the bulk of people. I think there are a lot of people out there that like some of the ideas, but not all of the ideas of the ecological approach. For example, I think many think the idea of using tau or optic flow to control actions is good. They just believe there's more to the story. Well, as I've hopefully explained here today, there's an easy out if this is your reason. You can incorporate online information sources like tau and optic flow into indirect models of perception that use Bayes models, for example. You don't need to buy into the ideas of direct perception at all. Finally, reason number 3. Maybe there's some people out there that have a different definition of what we mean by quote-unquote direct perception than Gibson proposed and that's used in ecological dynamics. I'm not sure what this might be, but I'm open to ideas. The bottom line is that today I'm not trying to argue which theory is correct, indirect versus direct perception, although obviously you know what I think. I'm just trying to say that in many cases when people think they're integrating these ideas, they are not. They're really saying indirect perception is correct and direct perception is wrong, which is totally fine, but I think it's critical to acknowledge that's what you're doing. You're not somehow being more open and inclusive of ideas when you create indirect models with both online and offline information. You're picking a side, just like I am. Okay, that's it for today's episode. Remember, you can contact me at robgray@asu.edu or follow me on Twitter at Shakeuates. To find out more about the podcast, please check out perceptionaction.com. Finally, to support the podcast and receive bonus materials, including written transcripts, please head over to patreon.com/perceptionaction. This is Rob Gray from ASU. Cheers for now, and keep 'em coupled.